Hello Legacy Sabers, Marsh here. So today we're going to solve systems of equations. You're going to want your notebook, a pen or a pencil to write with, and you may need a calculator to do some simple calculations as well. So learning goals today. I can solve a system of linear equations using substitution, and also I can solve a system of linear equations using elimination. Now, we just did graphing yesterday. So graphing has some limitations. You can't graph every single one. So notice here I have a system of equations. Y equals negative x plus 2 and y equals 2x minus 5. And notice the solution would be right here where they cross. Notice, guys, that is not a nice area for a solution. It is a hard number. It's not perfectly lined up. So that way, graphing does have some limitations. We can't graph every single one of these, so we need some other methods to use to solve. So, what are the other methods? Method 1, graphing. We've seen that one. Method 2 is known as substitution. And then method 3 is elimination or linear combination. Both words work for that. We're first going to talk about, however, is substitution. We're going to talk about how do you use substitution to solve a system of equations. So, what does it mean to have a substitute? Well, when you are substituting something, it means that you are putting it in place, right? If I have a substitute teacher, that means that they are coming in place of me, right? If you substitute something in a restaurant, you're saying, I don't want this, but could you please give me this instead? What we're doing is you're replacing something with something that's of equal value. So, what do you do when you do substitution? Basically, what it means is to replace. So, we're going to substitute one equation into the other. So basically, your first step in substitution is you want one of the equations to be solved for a variable. It does not matter if it's x, it does not matter if it's y. You just need to have one of the equations solved for a variable. So I notice the top equation here, I am solved for y. My first step is done. Now what I need to do is substitute into the bottom equation. Where I see a y, I'm going to put the 7 minus 2x because y is equal to 7 minus 2x. It's an equivalent statement. I know that they are equal to one another. So what I'm going to do is instead of putting a y in here, I'm going to actually put what y is equal to. So 3x plus 3. Now, y is equal to 7 minus 2x. That's me calling in, hey, substitute, come here, I need to solve. So you're substituting in the 7 minus 2x. This is equal to 9. Notice it's just like this equation, except for the y, though, I put his substitute in there. Calling in a substitute, kind of like in football. So I got 3x plus 3 times 7, that would be 21. Minus 6x equals 9. Notice, guys, what did substitution do for us? It got rid of the two variables in one equation. I'm now all x's. I now can solve, because you can't solve when you have more than one variable. Otherwise, you'll have a literal equation. This time, I am actually able to solve for x since I did my substitution. So 3x and a negative 6x, that is a negative 3x. I'm going to subtract the 21 to the other side. Basically, I'm solving for x here. I'm going to get negative 12. 9 minus 21. Divided by negative 3. I'm going to get x equals 4. Now, I need to go further because remember, guys, our answers when we did our graphing, it was an x and a y. So you do need the x and the y coordinate to be able to be done. So what are we going to do? We're going to take this 4 and plug it into one of the two equations. I like to plug it into the one where the y is already solved for. Just because it's going to be easier math, you could plug it into the bottom. You'll get the same equation as me after you do some algebraic manipulation. So I'm going to get y equals 7 minus 2 times 4. Y equals 7 negative 2 times 4, that's negative 8. So I'm going to get negative 1. So y equals negative 1. Now, just like when we did our graphing, the final answer was the solution, the ordered pair. You do need to write your ordered pair out. That's going to be 4, negative 1. How can you check this to make sure you're doing it correctly? What you could do is take those 2 points, 4 and negative 1, and plug it into both equations. They should work out. If they don't, algebra somewhere got messed up. Let's check another one here. So I got negative 4x minus y equals 2, and 7x plus 2y equals negative 5. Notice, guys, there is not a variable solved for yet. So we got to do our first step. Let's get a variable solved for. I'm going to solve for y. I notice he does not have a coefficient or a number in front of him. Makes me a lot easier, not as hard of math. No fractions are going to come out of this. So I'm going to solve for y. There we go. Let's add 4x to the other side. Then it looks like I need to divide by a negative 1. So I know y is equal to negative 4x minus 2. Now, what I'm going to do is take this negative 4x minus 2 and plug it into my bottom equation. I'm going to go, okay, substitute, because I got to substitute in for y, so I don't have any more y's in my equations. So I will have 7x plus 2 times, not just y though, not y, because y is equal to negative 4x minus 2, and that equals negative 5. Let's start my solving process here. So, do my distributive property. I got 7x minus 8x, that is negative 1x, minus 4 equals negative 5. Add my 4 to both sides. Negative 1 divided by negative 1. So I get x equals a positive 1. Now, let us plug that back in. Now, you can plug it into either of these 3, technically, equations. I like to plug into the original, just because that makes sure I didn't screw up anywhere. So I'm going to do the negative 4x minus y equals 2. Not as hard of math. So negative 4 times 1 minus y equals 2. So I get negative 4 minus y equals 2. Add 4 to both sides. Negative y equals 6. So y must be equal to negative 6. Just because the negative, I'll divide by negative 1, right? So my solution to my system is the point 1, negative 6. Now let's look at the other way we can solve a system. So we've went through graphing, we went through substitution. Now let's look at linear combination or elimination, depending on how you want to call it. Now, what does this actually mean? Linear combination. So linear, it deals with lines. Combination is putting things together. And elimination is taking something out. So ultimately, guys, what are we ultimately going to do during this kind of method? We are going to add equations together, and this is going to allow us to eliminate one of the variables, either the x or the y. So we're going to take the 2 equations, add them together, and hopefully we will force it so that one of the variables will eliminate the other. Kind of like the eliminator. We're going to eliminate one of the variables. So, let's try it here. So, I need to eliminate one of the variables when I would add these 2 equations together. So, I have 5x plus y equals 6. Negative 5x plus 3y equals negative 22. So, technically, if I add these 2 together, I need one of the variables to cancel each other out. Let's see if it's going to do it for us right away. So I have 5x minus, or 5x plus a negative 5x. Well, that's going to cancel out, right? You're going to get 0. That's good. So ultimately, guys, what you need to have is what's called an additive inverse of one another. AKA, they need to be the same number. One needs to be positive, one needs to be negative. That is going to be the goal. Not all systems allow you immediately to cancel out. Sometimes you're going to have to do some manipulation, and I'll show you a couple of examples of that next here. But let's continue our problem here. So I have y plus 3y, that is 4y. 6 plus a negative 22 is a negative 16. Notice what I now have after adding those two equations together. I have 4y equals negative 16. I have eliminated a variable. Makes my life easier. So let's divide by 4. So I'm going to get y equals negative 4. Notice how that is good now. Let's plug that back in just like you did with substitution. Let's plug it in to get our x value. So I'm going to have 5x plus a negative 4 equals 6. So technically I have 5x minus 4, right? If I add my 4 to both sides, so I'll get 5x equals 10. Divide by 5. X equals 2. So my ordered pair is the point 2, negative 4. That's where those two equations, if I would graph them, would cross over one another. Let's try another example. So I have 3x minus 4y equals negative 5, and negative x plus 3y equals negative 5. Notice, guys, if I would add these two equations as they stand, notice they will not cancel each other out. I'd get 2x and a negative y. I need one of them to cancel. Here's where manipulation's going to need to happen. I need them to be the same number, but one positive, one negative. Either the x's need to do this or the y's need to do this. I notice that the x's are probably going to be easier to do this. So I have a positive 3 here. I'm going to need a negative 3 here. Notice I already have the negative. So technically, I'm going to multiply these by a positive 3, the bottom equation. All you're doing, you're creating an equivalent expression. You're not changing it in the fact that you could just divide by that 3 and it would be gone. So let us see what we now have for our new equation. I'm going to have negative 3x plus 9y equals negative 15. Now notice if I add these two equations together, your x's are now going to cancel out. That makes our life easier. Negative 4y plus 9y, that is a 5y. Negative 20. Whew. Now I can solve for my y. It's super quick. Y equals negative 4. Now, plugging him back in, we're going to get 3x minus 4 times negative 4 equals negative 5. 3x plus 16 equals negative 5, it looks like. If I subtract the 16, we'll get negative 21 divided by 3. So x looks like he is negative 7. So my ordered pair, whoops, is negative 7, negative 4. Final one of the night. So I have x minus 2y equals 4, 3x minus 6y equals 8. Notice, guys, I cannot cancel as of right now. So let's get it so that the x's are going to cancel out again. Notice I am both positive, so I do know I need to make one of them negative. So I'm probably going to multiply by a negative number. I need to get so that it's a negative 3 up here, right? Because I need these two to cancel. So ultimately, let's multiply by a negative 3 to the top equation. So if I do that, I will get negative 3x plus 6y equals negative 12. Notice, cancels. Ooh, that's going to cancel too. So I'm going to get 0 equals negative 4. That's strange. 0 doesn't equal negative 4. You know what this is? These are two parallel lines. So this is a no solution. They have no solution. They are parallel, thus they will not cross. There's another one that you can get like this that looks like 0 equals 0 after you solve. If you get another equation, they basically are the same equation with a multiple. This is known as infinitely many. And we'll take a look at one of those in class when you get back to class with me, okay? But keep that in mind. That's another option you might get of one of those special kind of systems that are kind of different. And that's the end of this video. See you later, Sabers.